My presentation today is going to be on albatrosses. A little bit of their overview. They're from the family Diomedidae, and there are four genera: Diomedea, the great albatrosses, Thalassocari, the molly-mallywauks, Phoeobasteria, the North Pacific albatrosses, and Phoeobateria, the Sudi albatrosses. There are 21 extant species and 19 are currently threatened with extinction. This is their phylogeny tree, which shows their outgroup Procellaridae and the four genera and a few of the species within each one. A little bit about their morphology. Their beaks have an upper mandible that hooks, which helps them when catching prey when diving into the water. Their tube nostrils are on the side of their beak, unlike most birds, which have theirs on the top. And this actually allows for the albatrosses to have an acute sense of smell, which they use when foraging on the land to determine if something is food or not. They have strong legs, which also help them walk very well on land, and 3 webbed toes, which are particularly useful whenever they're trying to run on the water to get lift for takeoff. Their wings are stiff, cambered, and streamlined. Cambered meaning that the air flies over them and helps provide lift as well. And the great albatrosses have the largest wingspan of any birds, which can measure up to 11 feet across. A little bit about their diet. They eat cephalopods, such as octopus and shrimp, or squids, crustaceans, such as shrimp and krill, and fish. Sometimes they scavenge carrion, which are dead animals, or feed on zooplankton. Squids are usually too large to be caught alive, so they're usually eaten dead. They feed by surface feeding, diving, and plunge diving. They can dive up to 12.5 meters just to catch a meal, and they feed during the day. Their flight is really interesting because their heart rate while flying is actually very similar to their basal heart rate while resting, and it allows for the coverage of great distances without expending that much energy. What requires the most energy for them is hunting, takeoffs, and landings. It's so easy for them to fly because of a shoulder lock tendon, which keeps their wings fully expanded without using any muscles, and this keeps their heart rate low while they're flying because they aren't doing that much work to stay in the air. They're very weather pattern dependent though, and without the wind it's difficult for them to fly, and if there isn't much wind at a certain point in time, they'll rest on the ocean surface until it picks back up again. They use 2 flight techniques. The first is dynamic soaring, which they use by gaining energy from a vertical wind gradient when they're trying to lift up off further away from the ocean surface. And they also use slope soaring by turning their wing towards the wind and then gliding downwards back toward the ocean surface. Here's a video of them flying, which I think looked pretty cool. So you can see how they have to flap their wings to get takeoff. And they're running on the water in this video too.
And outside, on the open sea, adults flew with the grace the young birds will soon have.
In this little clip, you can see how they're lifting up away from the water and then back down towards it and up again using their 2 different flight techniques. And then this is a way to see how massive their wingspans actually are. So a little bit about their distribution and range at sea. They're found in higher latitudes, avoiding the doldrums, which are areas near the equator with low wind. And most species are found in the southern hemisphere, but a few have been found in North Pacific and in the Galapagos. The species in the Galapagos are able to survive there because of the Humboldt current, which gives them lift. They don't experience any annual migration and disperse after breeding. The ranges at which they disperse depend on the species and the sex. They nest on isolated islands or exposed headlands near the water. They all originated on islands that previously didn't have any mammals on them, which these mammals are now responsible for the decrease in their numbers because they're taking their eggs. And the nest can vary from very large groups to spaced individual nests. In this picture, you can see that there are a lot of albatrosses here nesting together. Their breeding is philopatric, which means that they breed in the same area that they were born. They don't reach maturity until after 5 years, but they still wait a few more years after that to breed, which allows them to invest more time into fewer offspring. They spend years practicing breeding dances and perfecting them. They will dance with less and less birds each season until they find the one that they believe is perfect. And once they find them, they perfect their dance for them, and the pair form a lifelong bond. One egg is laid each breeding season, but may not be laid every single breeding season. There are usually gap years where an egg is not laid. The nest may or may not be made depending on the species. The egg is incubated for 70 to 80 days by each parent in turns, and this is a very energetically demanding process, and the parents can lose a lot of weight while incubating the eggs. After hatching, the chick is guarded for 3 weeks by the parent, and it's fed by both parent at intervals. They usually feed on fresh squid, krill, and fish and a stomach oil that their parents produce, which provide a lot of nutrients for them to get as big as their parents are. The chicks fledge 140 to 280 days after hatching, which the parents are unaware of. They're usually out getting food, and then they come back and realize that their chick is left. In conclusion, they're very large birds. They're excellent long-distance gliders, and they spend most of their time over the water. They also take care of their young and mate for life, which I think is pretty interesting. These are my references. Thank you.